So just like tides, we're going to start by having a problem where you get asked to find the time and speed of a certain current, either a flood or an ebb, at a substation. So we'll do this by finding the correction factors to that substation and then applying them to the relevant not high or low, flood or ebb of the main station it's based off of. So let's do the race. Let's say, what is the time and speed of the first ebb current at, no, I think the race is a main station. I'll just pick a random one. We'll pick where we're going to be finding this off of in a second. Oh yeah, and the day will be like March 18th. So step one is to go into the index to find your station, but I can't think of one off the top of my head, so we're doing this to pick one in the first place. I'm going to say in advance, this might be cause some issues because I know that not just the PDF here, but also the physical copies of the book tend to sometimes be missing pages. So it's possible that the one we find won't actually be usable. But we come to the index here. Crab Point, that sounds cool. So we'll put that into the problem and say that the problem is asking you about Crab Point here. Number 4336. Just like everything else, write the reference number first. Crab Point. Okay. So the next step is then to use 4336 and find our information for that station. So that's the 500s. You can see right there we skipped a couple hundred reference numbers. That's what I mean by we're missing a few pages. Now we're at the 5,000s, 4,400, 4336, Crab Point, technically a half a mile east of Crab Point. Whatever, that still is valid. So I guess out of curiosity, the first thing we should check before we even get into the correction factors is just what our main station is, so you can see Delaware Bay entrance. Okay, so this is somewhere on the Delaware River. So Crab Point, there it is again. We'll just try to keep our place there. As you can see, we're copying over a lot more information this time. So remember, what we're getting is the time difference for a minimum before a flood, so a slack water before a flood, time difference for a flood, minimum for an ebb, and then the speed ratios. So I confirm, okay. So for Crab Point, the minimum before a flood occurs 4 hours, 48 minutes after it does at Delaware Bay entrance. And then the flood is 4 hours, 44 minutes. So to not get overwhelmed with numbers, we're just gonna write those first. So So the correction factor for a minimum before a flood is 4 hours, 48 minutes, and for a flood is 4 hours, 44 minutes, both later than. And we'll just write here so we don't forget, on Delaware Bay, or river entrance, Delaware River entrance. So now we'll get the information for the ebb currents. Okay. So there's our floods. 4 hours, 44 minutes for the minimum before an ebb, and 4 hours, 50 for the ebb. So plus 444 and plus 450. So you can see, obviously, the numbers tend to be pretty similar because basically the whole tidal cycle is just being offset right around 4 hours, 40-ish minutes for all of these. It's still preserving the same relationship between them. And then we'll get for speeds, flood, and ebb. This will be the speed ratios off to the side here. Okay. You can see, where is it? 4 hours, 48, 44, 44, 1.2 and 1.0 as the flood and ebb speed ratios. So what that means is that you multiply the speed of the flood at Delaware, at the Delaware River entrance by 1.2 and the ebb by 1.0. All right, now that we have all of this, our next problem is to find the information for the main station. So we come back to the book. We're going to jump up to the main station page, which I've written down here. Okay, main stations start at 9, so we're going to go to like 15 and hope that's reasonable. Boston Harbor. Okay, so I have to go a little down then. Cape Cod. Pollock Rip, still in Massachusetts. Okay, we're down to New York. Delaware Bay entrance. Oh, I was right the first time, never mind. Okay, Delaware Bay entrance. We are looking for March 18th, the first ebb. Okay. So we actually happen to be at March right here. 17th, 18th. So remember how we read this. It goes across and then back and down, across, back and down, across, back and down. So you can see the offset here is because the minimum that occurred before this one right here happened the day before. So we've got at 23:39, it was a slack water on the 17th. Then at 2:48, it was an ebb current of a speed of 1.9. And then at 0403, I think that's a 4. Yeah, 0403, it was a slack water again. So as usual, you do technically only need to take this number here, but I want to take everything around it just for practice and because it's always possible that these things get shifted out of alignment and then a new ebb becomes the first ebb of the day. So we're going to do, we're going to take just the 4 around it. So starting from this one to here, to here, to here. So 23:39 was a slack water. First, we got to set up a little table for it all, though. Let's see. Okay. Here's how we'll do this. 23:39, speed of 0.0. Then our next one, or time, speed. Then our next one was 0248, 1.9 ebb. 0248, 1.9 ebb. And we can assume this is probably going to be the first ebb current of the day because it is at the main station, so it probably is at the substation. Next we'll take 0806. I can't even tell. 6 makes more sense. 0603. 0603, which is another slack water. And then 0902, which is 1.3 flood. 0902 is 1.3 flood. So I legitimately, like, it was so misprinted. There was no way of telling if this was a 6 or an 8. However, you can see these times are almost always 3 hours apart because now we're breaking the 6-hour cycle down to a 3-hour cycle because we're breaking it into more parts. So it kind of has to be 6, but that's just an educated understanding of the currents, not being able to read this book. So you should be prepared for this book to be illegible sometimes. All right, now that we have these, we're going to apply our corrections to each of them. So we'll start here. 2339, it's a slack water, meaning it's a minimum, and the very next thing that occurs is an ebb current. So it's a minimum before an ebb, meaning we need this this correction here. So plus 0444. This right here is an ebb. So we apply this correction plus 0450. And because it's an ebb current and it actually has a speed, we multiply it by 1.0. We don't multiply this by anything because it's 0 times 0. Like, it doesn't matter. Now we've got a minimum before a flood. So we're going to take this one over. We'll do plus 0448. And again, it's a slack water, so it doesn't, speeds mean nothing. And then the correction for a flood. So plus 0444, and we multiply it by 1.2. So then what we get over here is all of our true times and speeds. Time, speed. So starting here, we add 4 hours, 44 minutes to 2339. So plus 4 hours would give it 0300 plus 39 plus 44 is not one I necessarily want to do in my head. So 39 plus 44, we get 83. We subtract 60 because that carried over an extra hour. 23, and I already said that we added, we were at 3 o'clock from adding the hours, so we get 0423 with a speed of 0.0 because it's slack water. And then we add 4 hours, 50 minutes to this one. So you can see 2 plus 4 is going to be 6. Then we're going to have to carry over another one, so it's going to be 07. And then 48 plus 50 is 38. So 0738. The speed correction is just times 1, so it's exactly what it was. So we get 1.9 ebb. Then at 0603, we add 4 hours, 48 minutes again. So that'll give us 10:51. And it's a slack water, so it's 0. Then we add 4 hours, 44 minutes to 9:02. So that's going to give us 1346 multiplied by 1.2. So 1.3 times 1.2. 1.56 flood. 1.56 flood. So, like I said, all of these ones here were extraneous because we know that they weren't going to apply to us. We were only ever looking for this ebb current here. You could say, though, remember we just shifted every single time down 4 hours. So now we've only started the looking 4 hour at 4 in the morning, meaning there is, if this is a slack water, there is a flood. This is a slack water before an ebb, meaning it's a slack water after a flood. So there was some flood current that happened earlier in the day, probably at like 1 in the morning, and then another slack water before an ebb that was some 3 or so hours before that. Meaning, technically, we should have brought those over too, just to be safe. But because we know that this was a minimum before an ebb, meaning we know that this had to be a flood, meaning this had to be a minimum before a flood, there was no shot that this ebb that happened even before that was any time during this day. So that means that this one right here is the first ebb current of the day. It occurred at 0738 and had a speed of 1.9 knots. So that's our answer. That's how you would find the time and speed of a certain max current. Or you could do this for a slack water off of a substation.